Okay, moving on to the last page. We need to graph these functions. Okay, so the first thing I'm going to do is make a parent table. So the parent table is going to be y is equal to the square root of x. And so let's use these values. 0, 1, 4, and 9. And so the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Now we're going to shift that table, and what we see is we have a negative 3. That's going to multiply by the y, so here's the shift table. That's the full table for this thing. And what we're going to do is we're going to take the y value times a negative 3 plus 3, and the x value, remember, so this is x minus h, so h is actually equal to a negative 3. So the x is going to have to be x minus 3. Right, so let's take 0 minus 3, that's a negative 3. 0 times a negative 3, that'd be 0 plus 3 is 3. Let's move to the next point, 1. 1 minus 3 is negative 2. 1. So I've got a negative 3 times 1. It's negative 3 plus 3. That'd be 0. The 4. 4 minus 3 is 1. 2. Negative 6 plus 3. Negative 6 plus 3. And then lastly, I have 9 minus 3 is 6. And then I've got 3, so I've got a negative 3 times 3. That's a negative 9 plus 3, that's a negative 6. So let's plot that. Negative 3. Positive 3. Negative 2, 0. 1, negative 3. And 6, negative 6. So my graph would look like this. And did it say to find the domain? Probably. Yep. So the domain is x greater than or equal to this negative 3. Which in interval notation would look like this. Actually, it's going to have greater than or equal to, that would be a closed bracket. And the y is going to be everything below 3, so the range, all reals, y is less than or equal to 3, which we would write in interval notation as a negative infinity going all the way up to 3 with a closed bracket. Okay, the next one's a cube root. I'm going to do the same thing. We're going to say my parent table is y is equal to the cube root of x. And let's give us the values to use. I'm going to use 0, gives me 0. I'm going to use 1, the cube root of 1 is 1, and I'm going to use the cube root of 8 is 2. The next cube root is 27. It's not going to be on my graph, so that's enough. Now we're going to shift that. H is going to be equal to 3 in this thing. So I've got the y is equal to a negative 2 times the cube root of x minus 3 plus 1, and the table for that. Is going to be the y is going to be a negative 2 times y and the x is going to be x plus 3. So 0, 0, that would be x. 0 plus 3 is 3. Put 0 in for y, I get 1. I got 1, 1, so 1 plus 3 is 4. Over here I have a negative 2 times 1, that's a negative 2 plus 1. It's a negative 1. Now I have 8. 8 plus 3 is 11. I have 2, so a negative 2 times 2 is a negative 4. Plus 1 is a negative 3. So 3, 1. I have 4, negative 1. And I have 11, negative 3. Well, this isn't working out too well. And actually, since it's a cube root, I made a mistake at the start. I could have put some negative values in there. So let's go ahead. I can have a negative 1. The cube root of that's a negative 1. So down here, if I had an x value of a negative 1 plus 3, that would be 2. Y value is a negative 1. So negative 1 times negative 2, that would be 3. So I would have the point 2, 3. And let's put one more point on there. So I could also have a negative 8. I get a negative 2. So if I put a negative 8 down here, negative 8 plus 3, that's a negative 5. And if I put a negative 2 in for y, negative 2, that'd be 4, plus 1 is 5. So I've got a negative 5, positive 5. And so what this graph would look like, something like that. And you can see that there's no limitations for the domain and range. So the domain is all reals, negative infinity to infinity. The range is all reals, negative infinity to infinity. Let's see if there's anything more. Yep, one more problem I know. Okay, let G be a horizontal stretch by a factor of 2. So horizontal stretch, that's going to be an x stretch. So horizontal, this is going to be an x, followed by a translation of 4 units left, and then 3 units up. Okay, so this is what this would be. So I'm going to have so G of x is, now what I'm going to have is, since it's a horizontal stretch by a factor of 2, so the x is going to increase by 2. That means what I'm actually going to multiply the x by inside the equation would be 1/2. So I'm going to have 1/2. And then what's going to happen is the shift for the x, it says translation left. So that's moving this direction. That's also an x movement. And that x movement would be a negative 4. So remember, inside we have x minus h. So x minus a negative 4 would be x plus 4. And it's a square root. And that's the x part. And then it says I go 3 units up. So plus 3. So we could also then simplify that. Would be another way to write it. And I think that's it. Nope, there's still more. Okay, it says describe the transformation represented by G. So I need to describe it. So what we have is, we see that we have a cube root. We have a negative 1/2 on the outside. That is not affecting the x. So the first thing, I'm just going to write them in kind of order here. I'm going to have a reflection across the x-axis. That's what this negative will do. Then this 1/2 is going to multiply by the y. Y is vertical, so it's going to be a vertical shrink by a factor of 1/2. Okay, and then we can see that I also have this -3 at the end that is not affecting the x. That also affects the y. That would be a shift down by 3 units. Okay, how are a function and its inverse related graphically? Okay, it's one thing we could say, it's a reflection. The points are reflected across points are reflected across the line y equals x. Another thing we can say is that the x and y values are switched. And that's it.